you might have noticed that I changed a little the title of my presentation, because in the placard that we have, the title was slightly different. And I changed it in the form that Anya so kindly introduced, because I really want to take advantage of the possibility to discuss with you about my project. Because the original title is the one you will see here, was The Future of Prediction, which is the title of the ERC project that well, generally supports our research. And actually the real title of the project is The Future of Prediction, Social Consequences of Algorithmic Forecast in Insurance, Medicine and Policing. It is a real sociological project where we want to explore this topic. And I would love to talk about it because I'm very passionate about my project. But as I said, I thought also discussing with Anya to use this opportunity to discuss something which is the theoretical background of the project and which is less sociological empirical and more theoretical risky. So it's really a work in progress. I think I've been working on that quite long, so I think I have enough empirical material to have something to discuss with material that I gathered on the topic. To, I hope, have a good discussion with you and to take advantage of your feedback. But as you will see, especially at the end, I'm still struggling with the way to work with the material. I start with a short introduction of the problem of this divinatory feature of algorithmic prediction, and then I will develop my argument. And I will begin with something which happened as often as the case, almost by coincidence, because 2 days ago on Saturday, David and I were in Berlin and we visited an exhibit at the CO Museum of Photography in Berlin with the name The Songs of the Sky. And the first, epigraph, so the full presentation of the exhibit was this one. For centuries, we've looked to the sky to divine the future. Today, we look to the cloud, which is, in a sense, a kind of summary of what I want to discuss with you now, because the cloud stays for the divinatory procedure we use now, and the cloud is called more than that. But my topic was how now the cloud or divinatory algorithmic procedure are, in a sense, inheriting a kind of, attitude or effort to know something about the future, which used to be something which is for our culture not so familiar, and we tend to refer rather to divinatory procedures. The starting point of my research was actually something that struck me while working with algorithm digital features, that very, very often algorithms are presented and discussed as oracles. And not only also, but not specifically in humanities or in the popular literature, specifically in the people who work in the field. Programmers and designers, computer scientists tend more and more to talk of they say oracles, but the features they described are, I would say, I will go more in detail further, divinatory features of the way to work of algorithm. For example, Alessandro Vespignani, who directs the Network Institute of Northeastern University. He's a very, very famous digital epidemiologist and works in the field. Wrote a book 2 years ago, I think, or 1 year ago, with the Italian title, he was in the US, but it probably was published in Italian, L'algoritmo e l'oracolo, which means that the algorithm and the oracle, where he writes that algorithms are closer to fulfilling the desire for a secret-free, completely predictable tomorrow. And he's an informatician. Pedro Domingos, if you work in computer science, you certainly met the name. He's a very famous leader research in machine learning and in inference under uncertainty. And he wrote a book with the name The Master Algorithm, which was very much received in the field, so a risky book. But he writes too, the ultimate master algorithm can derive all knowledge in the world, past, present, and future, from data. And this formula knowledge of the world, past, present, and future, is exactly what you find in algorithmic procedures. And I found it interesting. I found this fascinating, because these claims here are not isolated. I selected these two, but there are so many others you can find. The more you look into the literature, the more you find a quotation with this kind of a claim, especially since, especially among people who are working with machine learning and with the so-called big data, which is especially something that happened in the last 10-15 years. The new wave of AI you certainly heard about. And well, they talk, and I will talk here about algorithms referring to that. And of course, this usage is widespread, so that's why I confirm to it. But of course, we know it's quite imprecise. When in this debate, one talks of algorithm referring to this machine learning procedure using big data. Of course, algorithms are much more than that. Algorithms are concerned computers since the very beginning, and the word, as you know, was developed in the 17th century. So that's not precise to say algorithms, but well, with this warning, I will go on using that. When I say algorithm, I mean that machine learning procedure, especially the one working with big data. So in this is the idea, reference to oracular feature, to knowing the future in advance, is very common, and it is, I think, quite a remarkable trend, because in our society, the idea that you kind of know the future in advance, that tomorrow will be secret, free, and completely predictable, is very unusual. I don't have to say it here, because here everybody works about the future. So no, all the debate about the open future, and that's what I'm referring to. So since a couple of centuries, our society, modern society, has been guided by an opposite attitude. The idea that our future is an open future, which basically means inherently unpredictable future. I refer here mostly to the way the open future has been theorized by Rainer Koselleck, by Niklas Luhmann, as a typical modern way of approaching the future. And, I simplify, we can discuss it, but what's relevant for my argument is that the ocean future is radically unpredictable, because nobody can know the future in advance, not even God, for the simple reason the future does not yet exist. The future will produce by our action, by our decision, that are also guided by our projection of the future. So it is a future in which the idea of knowing it in advance, strictly speaking, doesn't make a lot of sense. And it is, since a couple of centuries, I will say more about that, something that we all take for granted in our way of referring to what the days to come, and so much that it also has certain normative features. The idea of self-determination and freedom of individuals is also related to the idea of the open future. So much that when with algorithms or with other procedure, we have the impression that the openness of the future can be endangered, we react with negative attitudes. But when people speak of preemption with very worthy attitude, the idea of that the future can be colonized or emptied by our present decision, that the openness of the future can be endangered. We don't like it. So, the open future, even if it is unpredictable, is fundamental feature of our society. Also, for this reason, the claim that we find now connected with algorithms are, in my opinion, relatively strange and also fascinating, because they are not connected with our modern semantics, and our modern attitude to the future, but rather, so that the title of my talk, with something much older, rather with the attitude of divination, which was very widespread for a long, long time until the Middle Ages, especially in the Middle East, in China, but also in our society, as an effort to gain information about a problem, a present problem, but especially also to know, to foretell the future, to know something in advance about the future, through basic techniques that read sign in a systematic way to disclose the hidden significance of these signs. There are practices that I said were very widespread, and in general, historical research shows that have been marginalized in a sense. They still exist, but are not taken so seriously since a modern time. Many people say they have been marginalized by the prevalence of our Galilean scientific methods, which we will say more something about that, is from many points of view incompatible with the divinatory attitudes. So what I want to discuss today here, or try to explore with you, is why the promise to predict the future is now so widespread with these new algorithmic techniques. Is there anything in the way algorithm works that leads to think that one can know the future in advance? And how is this connected with the idea of the open future, which in our society is very difficult to refuse? Or basically, what is the connection, if there is any, between divination and digital practices? Or even more, how does the emergence of these, let's say, para-divinatory features in algorithmic technique affect the relationship with the future in our digital society? Is it modern, it's not modern, it is postmodern? How does it deal with that? Before developing my argument, I have to make a premise. When I talk of divination here, I don't mean divination as simple superstition, as something really negative. And when I say that algorithm might have an affinity with divination, I don't mean at all that the algorithms are superstitious or irrational or something negative. But rather, if anything, that they might rely on a different form of rationality, or possibly, and that's also very much discussed in the field, of a different way to deal with the cause-effect relationships. And that's also something that is present in study about divination. Well, the idea that divination is not irrational has been discussed since at least a couple of decades. Some of you might have read that there was a book in the 70s by Jean-Pierre Vernant and others with the name Divination, Rationality, which has been translated everywhere, which explores especially this claim that divination has its own specific form of rationality, which relies on different premises and develops different procedures that that are familiar to us in our modern society. And that the research explored this rationality in very different cultures. First of all, Mesopotamia. Mesopotamia is the first reference for divinatory technique, and then China, India, African societies, and so on. But I also find interesting, while I was exploring this field, that in Assyriology, the study about ancient Mesopotamia, and Mesopotamia is the reference when you work about divination, the debate about the sort of scientific or similarly scientific status of, well, divinatory procedures, most in Mesopotamia astrology, is being discussed. There's an ongoing debate, which becomes lively in the recent time, since 10-15 years, about possible rational, similar scientific or scientific affine features of these Mesopotamian practices. And, it might be coincidence, but I found that the idea that this debate has become so lively as 10-15 years, just the same time with new algorithmic procedures were developed. I don't know what to make of it, but I found it in a sense also fascinating. So first, why do I claim there are divinatory feature in algorithmic prediction? What is divinatory about algorithmic prediction? I will present here a list of features that the research have highlighted both in divination and in algorithmic procedure that, it seems to me, show some fascinating correspondences about the two fields. I will show now some parallel more in details. First, the idea there are limits of human knowledge, intrinsic limit of human knowledge, which in the divinatory attitude were taken for granted. The idea that it's possible to know the future in advance doesn't mean that human beings can know the future in advance. This knowledge was in the ancient world accessible to gods, today possibly accessible to algorithms, but human beings cannot intrinsically get this knowledge. In the ancient world, Luhmann said that there was a knowledge insufficiency of human abilities to know the mystery, the deep structure of the world. And Francesca Rochberg, which is one of the most main authorities in studies about Mesopotamian divinatory features, this is a quote from her, writes that the idea that human beings could understand the ultimate order of nature would appear in a divinatory society an unacceptable hubris. It's not our task to understand the order of the world. Our knowledge cannot do that. It's basically intrinsically insufficient for that. The same formulation you find with algorithms. With these recent deep learning practices, we are moving towards a condition that, as David Weinberg writes, what we know depends upon the output of machines, the function of which we cannot follow, explain, or understand. And we should take this condition seriously as a basic condition of the work with algorithms. Algorithms have a fundamental opacity that cannot be overcome. These reasons are not all algorithms, this deep learning algorithm in many cases. They are basically obscure for everyone, even, I quote from Burrell, even for those with specialized trainings, even for computer scientists, even for the very programmers that design the algorithm. The algorithms are opaque, not understandable for everybody. And that's something we have to deal with, one of the big challenges related with these new techniques. That's one aspect, one, I think, interesting parallel. Another one is that in both cases you try to predict, but the prediction that one tries to get with divinatory techniques and with algorithm doesn't rely on an explanation of the underlying mechanisms. And this is connected with the first aspect, because if you cannot understand, of course you cannot explain. But if you cannot understand, you can nevertheless predict, because prediction, that's the claim of this semantics, does not necessarily require understanding. Divination was actually, that's very clear in the field, never interested in explanation, was not the goal of it. What the purpose was prediction, not explanation. That's the quote again. There are so many about it. And this purpose was pursued, prediction, not by explaining the mechanism, by observing regularities and exceptions in phenomena. You observe the phenomena and you can develop prediction without any need to understand not only need. One would never thought about understanding. That was not the mindset. One rather studied correspondences, which are revealed by the configuration and patterns that you can find in some objects, or selected objects, because that was very technical knowledge, typically entrailed of sacrificial animals, or in China, turtle shells, in I Ching, properly prepared, shapes of oil dropped in water, well, all kinds of shapes that you find in the world, patterns, that you have to explore to find this correspondence and to be able to predict the future or to predict the phenomenon. Something very similar happens in the work with algorithm. If you have read something in the field, patterns are the real main key word, and the people talk about working with algorithms. The aim of these machine learning procedures is not explaining, is not verification of hypotheses, but, as the people say, pattern detection. Algorithms are used to find patterns not in the object of the world, but in the big data, in the huge amount of data the algorithms are working with. And these patterns are, as in divination, correlation, that's a quote, among in this case, vast realms of data, where you find the correlation in order to develop your prediction. And you try to make prediction without trying to understand how and why things occur. That's exactly as in the case of divination. And in both cases, the assumption was there is an excess of signs. That's, as you know, that was the basis of the fascination of the infinitely productive world of divination. The whole universe had a divinatory value, in a divinatory worldview. The whole universe could be interpreted as a sign. The curiosity of the mineral and the vegetal world, the changes in the weather, the behavior of animals or of human beings, and of course the sky and the stars, which were, that's the topos, the stars were huge, heavily writing. That could be, if you know how to understand it, you can read this phenomena, and everything is a sign in a sense. Nagel describes this condition, this cosmological underpinning of divination, with the formula science, everywhere a sign. And that they are almost the same word they are used today to refer to the work of algorithms. Patterns everywhere. Algorithms derive these patterns not from the stars, but from the big data that can be collected from every aspect of the world. As in the case of divination, everything was a sign. In the big data, everything can be used to gather data that can be then interpreted looking for patterns. The materials on the web, all text, documents, video, blogs, all the things we found on the web, all kinds of files, the behavior of users, what we surf the web, our requests, our recommendation, comments, chats, so on, our movements, relationship, location, sensors in the Internet of Things, all these kind of things produce signs that can be interpreted if you know how to gather, to find patterns and to gather information. But also, and I think the most important part, the parallelism between divination and algorithms requires a concern the kind of predictions that they produce. Because with both techniques, you produce a prediction that are intrinsically different from the prediction we are familiar with in our modern society. First, in both cases, we have to deal with individual prediction, individual forecast. Divination always dealt with singular events. For example, the health, the happiness of specific people, particular events, like will the king be in good health? Is it advisable to start the battle tomorrow? Will the applicant wife give birth to a male child after so many females? A very individual specific event, not a trend. What will happen to a person, how an event will develop. The same individual reference can be found in algorithmic prediction, and especially in the field is called predictive analytics, the field that uses machine learning techniques to produce prediction. I have a quote. Whereas forecasting in this debate refers to our probabilistic way of developing prediction. Whereas forecasting estimates the total number of ice cream cones to be purchased next month in Nebraska, predictive analytics tell you which individual Nebraskans are more likely to be seen with a cone in hand. They don't predict trend, they predict what will happen to a particular person at a specific moment in time under specific condition. So the prediction say nothing about the population and nothing about averages. If you need averages, you need population, you have to gather a lot of predictions and combine them together. Exactly the opposite of what we are doing with our probabilistic techniques. Not only individual, this divinatory and algorithmic prediction are individual, but they are always contextual. In the ancient practice, it was clear, it was sort of a dogma, that context has to be used as a very important resource to making predictions. So divination always referred to a specific place and a specific time from which one had to draw the indication they were required to make a prediction. In the I Ching, for example, but also in other, I found some quotes, but it's everywhere, Van der Mesch studied Chinese divination with I Ching and said that there, in this kind of divination, everything depends on context. in algorithm today, in a very influential book by Andy Clark, you can read that the context, it seems, is everything. This personalized algorithmic prediction is, I said, not general, so that always applies to the available data set, to the targeted individual, and to the particular moment. The predictions are deeply, inherently contextual. If you need a different prediction, if I make a prediction about Anya today in Cologne, I cannot generalize to another person somewhere else, or even to Anya tomorrow. I have a different prediction, I have to start afresh. And if I had to combine the prediction, I have to find a way to make them compatible. But every prediction holds only for that specific context. And that's the way they work. Also, both kinds of predictions are performative. Well, performative is sort of recent, fashion word, but with the performative, I indicate that in both cases, people were aware that the predictions have concrete consequences. For example, in the case of oracles of divination, it was clear to everyone that the prediction tended to be self-fulfilling. Think about ordeals, of course, but think about Oedipus, that, as we know, tried to do everything possible to avoid his destiny, and it fulfilled by trying to avoid it. The prediction fulfills itself in the case of algorithms. So they are performative in the self-fulfilling sense, but also in the self-defeating sense. They have consequences in a way or the other. No? In the divinatory world, there was a lot of discussion about so-called apotropaic rituals. They were formalized rituals that were followed to avoid the prediction. So you try to talk with the gods to revise your individual fate. You have to follow this procedure to avoid the fulfillment of the prediction, and you could do it. So the prediction had real consequence in the course of the world because you do something that changes the course of things. The same happens with algorithms, to the point that Dominique Cardone clearly says that algorithms manufacture, I say, the future with their operation. They manufacture the future they anticipate, and thereby they performatively affect what they want to predict with a well-known circularity, which is, for sociology, of course, very fascinating. For example, on the self-fulfilling side, algorithms are used in predictive shopping to predict what a person would like to buy before the person is aware of this, and in many cases before the person even knows that the product exists. The algorithm proposes to you a product that you are not aware of, and possibly, if that works out, you buy it, and thereby the algorithm fulfills their prediction because they produce the conditions that make the prediction possible. That can happen, or algorithm can work also in a self-defeating case, as in the case of crime prediction, which is one of the fields we are exploring in the project, because for crime prevention, the algorithm claim to be able to identify criminal behavior, criminal tendencies before they are realized. Therefore, the prediction should make it possible to act before an individual begins a criminal career. So you defeat the future, you change the future in a form that makes the prediction false by the very fact that it's been predicted. This circularity is always present in the kind of individualized prediction, in the positive and the negative sense. So, I could go on, because the more you explore this field, as I've been trying to do for a long time, the more this parallelism stand out. You find more and more similarity between one field and the other. And if you do the interaction, you always tend to find what we are looking for. But I think that's in the case is quite striking. But I don't want to go more in detail, because I wanted to have some example with a quote to show what seems to me interesting parallelism. The question, and the reason why I said at the beginning the discussion with you today is sort of risky, is what I intend to do with that. So the question I want to ask is, so what? So there is a parallelism, they are similar. I'm a sociologist. What does it mean? What can we make out of that? What's the relevance of this well, I think quite surprising similarity between this product of the most advanced scientific development in our modern society and a trend that is understood in general as something which has nothing to do with our modern rationality. Because nevertheless, algorithms have this similarity to divination, but I don't think that in our society people are willing to adopt a divinatory attitude. The idea that to make decision looking at the liver of a lamb or look at the scary sky is not something that even people working in algorithm, we find plausible in our society. Our society has a very different, as I said, from modernity attitude towards this phenomenon. As Luhmann said, our society, since let's say since the 17th century, since some century, moved from divination to technique, and in the scientific field and in other fields of society, or as Luhmann said, from interpreting science to excluding simultaneities. I mean, science tends to show a simultaneous relationship between the sign and the referring object, but we tend to reason instead in form of causalities, and causality always imply a difference in time between the cause and effect. So that's one of the reasons why this kind of way of reasoning is very basically incompatible with our attitude. Or I found it fascinating look in this field. An old article by Carlo Ginzburg that I think probably many of you read, the one about an indiciary paradigm. It was 79. It's very, very famous. And in this essay, Ginzburg argues, for example, that the divinatory paradigm, which for him is the same of this indiziario in Italian paradigm, became irrational when the paradigm of modern experimental science was established. There's quite a lot of research claiming that divination became irrational, is considered irrational, when scientific rationalities, which also widespread in our aspect of our society, was established. For example, this, for me, very fascinating historical study, for example, by Laurent Dest or by Jan Hacking, about the establishment of calculus of probability, claim that they are the basis of modern empirical science, but they gave rise not only to modern science, but to a general form of rationality which is different in all aspects of our society. And also to a new approach to what was divination. It was the problem of prediction. Mathematical probabilities, which I recall, according to Dest and Hacking, according to many of us, is the basis of modern scientific experimental method, moved from individual cases to large numbers. That's the reason of the plausibility of probabilistic procedures. That, well, the single throw of a dice is completely random, and you cannot know about that, but if you have a big number of throws, a mass of throws, and a big number in the long run with large numbers, the individual deviation cancel each other, and you can reveal the regularity behind the apparent disorder of events. So an individual throw is completely unpredictable, but if you have a long run and many numbers, you can discover the regularity. And that's the basis of our scientific science, basically, in all fields. Well, it was the solution of the infamous or the Hume's problem of induction, the reason why experimental science, which is inductive, became plausible and accepted in our society. So this idea of rationality and the background of modern science rely on big number, on the huge general events, so they are actually general. They rely on big number, generality, on acontextuality, because the big number is referred to the single individual case, so general phenomenon, and tendential to abstract laws. That's why modern science works so well, but it's also why it has nothing to say about the phenomenon of divination dealt with. Ginzburg, as in the article, signaled it. It was one of his points. He says that statistics, as we know, has nothing to say about individual cases. Nobody has 1.4 children. So that's the discussion about statistics often criticize that. If you refer to individual cases, statistics doesn't hold. It holds because, of course, nobody has 1.4 children, but 1.4 children describes something at the level of the general population and can be extremely useful. So statistics says now about individual cases, and our science is not interested in individual cases as such. Divination looked at special cases, portents, monsters, strange individuals. They were listed, studied, classified, and so on. For example, if you look at this Mesopotamian treatise of divination, there were listed all these cases, livers with multiple gallbladders, 2, 3, 4, 5, 7, which is empirically impossible, but they were looking for specific cases. Cows with 2 heads, animals with strange forms, they were the basis of the interpretation of the natural world. And these phenomena these exceptions are not what modern science is interested in. They are taken into account only if they can contribute to the better understanding of the general trends. If these specific cases, the specific and idiosyncratic features are not interested by themselves, but only if they can help to understand better what is the goal of science, the normal, the general rule. And also the context that, as we saw, was a basic resource for divinatory technique, in modern science has become a source of disturbance. It has to be neutralized as much as possible. So you know that scientific results, in order to be recognized, has to be repeatable. So you have to be able to reproduce the same result in different contexts by different people at different times. So they have to be cleaned up, so to say, of all contextual elements that link them to the specificity of the situation and the specific moment. Also in statistics, the word is sampled with rigorous and controlled procedure in order to eliminate all contextual elements, and only then can become significant, can become rigorous in the sense of rationality. And that's a basic difference from divinatory procedures. But moreover, scientific observers are supposed to keep distance and not mess up to the object they are dealing with. The performative component, which, as we say, was a recognized feature of divinatory procedures, in our science, think about Heisenberg. The observer affecting the observed object is something which is a puzzle or a puzzle for natural sciences and a challenge, the possible form of irritation for the social sciences, but it's something which doesn't correspond to the standard procedures science refers to. So the basic components of divinatory practices, individual reference, contextuality, and performativity, are in a sense incompatible with the modern form of rationality, well, assuming that scientific rationality is a model for that. And this form of rationality is also the basis of our open future. Therefore, because our rationality relies on these general and contextual features, we don't have a science of individual prediction. Some people say we don't have a science of prediction, but I think we don't have a science of individual prediction, which was one we're referring to when talking with divination. No scientifically sound prediction, no matter how much information you collect, can tell you in advance who will have a car accident, when and where, who will lose their job, or whether a particular marriage will be successful. Just a question you asked to divination. What we can get with the scientific procedure is, if they are sound, if they are reliable, is which percentage of marriage can go wrong or can work, or the trends of labor market, not who will be fired, or how high the risk of accident is, not who will have an accident and when. That's how we work with the management of the open future. And in this perspective, the claim of divination and of algorithm now to predict individual happenings, individual event and precise facts, moreover, without explaining why you predict, because that's how divination and algorithm work, can all appear very, very strange, and in some cases absurd, and in any case raise a big debate. Yet it is exactly what algorithms claim. Predictive analytics claim that to be able to do that, predicting which people will drop out of school, cancel subscription, or get divorced before they even know it themselves. Exactly the kind of individualized prediction that's sort of banned of our culture. And I think this is, in my understanding, the most relevant connection between divinatory practice and these algorithmic procedures. Not so much the cosmological claim that was necessary in divination, that there was an order in the world that can be disclosed. Actually, algorithmic techniques don't require that. They don't require the assumption of an underlying order in the world. They work differently. But rather, I think, the effort to deal with that, according to Ginsburg, our science is not able to deal with. Individual reference, contextuality, and performativity. The problem is, how can we combine this claim with our still widespread and accepted form of rationality? How can this individualized prediction be combined in our generalized world, in a sense? Or how does this algorithmic form of prediction fit with the rationality criteria of the guarantee of controls of rationality of the world? Or, putting Ginsburg once more, can a divinatory, or we would say algorithm paradigm, be rigorous? How we control the rigor of this kind of techniques? This is, in my opinion, the real issue that underlies the discussion, the lively discussion that had been developed in the last 10, 15 years about the use of algorithm in scientific research. You probably heard about the debate that was triggered by Chris Anderson's article in 2008 on Wired about the end of theory. Someone read it. It was an extremely influential article that claimed that when you have algorithms, you don't need theory anymore, because the number, there are some only quote sentences, the numbers speak for themselves. You just have to find correlation, and since you cannot understand the algorithms, the procedure, you don't have to worry about it. If you rely on the machines, they will tell you how. What the quote, he also said, you don't need to ask why, just need the algorithm to show you what, and how that, at the end of theory, we don't need scientific theories anymore. And of course, it was provocative, it was worked as such, it was a huge debate, in which basically almost everyone did not agree with Anderson, but for 12 years, people keep talking and discussing that. And I think that's I found the debate in any case fascinating, but I don't think that the point is that science is not necessary anymore, that we need no theories anymore, but rather that the debate is now going actually in a different direction. I think that the direction that is being explored now is a possibility that through algorithm we might be in the condition to develop a genuine theory of prediction. A theory of prediction that does not comply with the criteria of our established science, generality and contextuality of modern science. That would be, in a sense, the bright side of the much discussed dark side of recent machine learning, especially deep learning. We have seen it. These procedures are very often incomprehensible to human observer, to everyone. Not even the programmers, as we said, who designed the algorithm understand how the machine works and why the machine does some moves. They are so multidimensional and basic for each of us incomprehensible. Therefore, this machine, that's the claim that Chris Anderson had, cannot be used to explain phenomena because nobody can understand, so nobody can explain. But the direction which is emerging now, they cannot use to explain, but they can be used to predict. The debate has shifted toward the possibility, we consider, of forecasting. That's a quote from a recent 2021 article. The possibility of forecasting without structured understanding. So the groundbreaking effect of these new machine learning techniques on science would be, I quote, to disrupt the functional relationship between prediction and explanation, which was taken for granted so far. So the idea that we always take for granted that you can predict only if you can explain phenomena. That a good prediction, which is not fantasy, which is not a cheat, should rely on the ability to explain the phenomena. If you can explain, then you can predict. And now, not so much a theoretical discussion, but the debate, observation, and the work of programmers goes in a different direction. Sarin Shmueli, a programmer in statistics, wrote some years ago an article, very fascinating in my reading, where she argues that it's not a big theoretical thing, that in the practice of digital modeling, predictive capability is now separated from explanatory capability. People want to explain, do some things, to predict, do very different things. And explanatory models are basically different from predictive model. They are different in the kind of data they use, in the selection of variables, in the methods, and most of all, in the criteria of validation. That without observation, theoretical observation, in the practice of programming, the two trends are now clearly separate. And this also that's the background of the also very much heated debate in the field about correlation and causation. You know, for scientific research rely on statistical procedure and in probabilistic research as such, the formula correlation is not causation is sort of a constant warning, because it's sort of a taken for granted warning against relying on correlation if you don't know the underlying causes, because you can make a lot of mistakes, and the people use statistics run always the risk to misinterpret correlation for causation. For example, there are so many examples that there's a correlation between ice cream sales and the rate of murder, but of course it doesn't mean that eating ice cream produces violent crimes and so on. The correlation is there, but if you don't know the causation, you can make a lot of mistakes. That's different with algorithms, because as I say, you cannot explain, and the work of algorithm is based, as we said, on mere correlation. Without understanding, you cannot understand, but you rely on correlation, and which you can explain in many cases. So without underlying causation, and these correlations are often very difficult to understand. Many people talk about spurious correlation, define correlation about crazy things. If you look on the web, there are also extreme entertaining correlation between the marriage rate in Nebraska and the consumption of butter. So apparently data have found this kind of correlation, which actually for us are not necessarily informative in a sense. But now the trend goes in a different direction, because you have this correlation. What do you deal with that? You have to control if the correlation is correct. If the correlation is correct, can you reliably claim that you don't need to explain the causality, because the complexity of the world is so high, and the complexity of the data algorithm deal with is so high, that not always we are able to discover the causation which is there, underlying that. But it doesn't mean that it's not correct. Maybe there are so many causal steps that the correlation is perfectly reliable, even if you cannot understand it. And if you can control the correlation, we don't need necessarily to check the causation. In a sense, people say, yes, correlation is not causation. Exactly. We just need correlation, not causation. They interpret the formula a different way. So one could think, and there's some research in the field, that this could be a kind of answer to Carlo Ginzburg's question. The question is now, through correlation, we can find a kind of criteria of rigor for predictions that they don't rely on explanation, they rely to the generality of the scientific method. The idea is that you can try to exploit the computational capability of the computer and the availability of so many data to make prediction techniques rigorous without relying on scientific explanation. That would be, some people say, a kind of paradigm shift now in the way to deal with data, which is not that you negate the scientific criteria for rigor. They remain, they are all very good. So that's, of course, it's legitimate, it's proper to continue to look for a causal explanation. But the claim would be, you don't necessarily always need to. It can be legitimate and probability control to look at the perspective, there's some emphasis on that, a perspective which, they say, is not driven by the proud claim to understand. So we have this proud idea that to understand, that there should be kind of blindness. In some cases, you can give up that because it's not needed. You can still understand what's required, but you accept something which you can understand when it works in a different way. And that's the first way to deal with that would be a proper science of prediction from this point of view. Because, well, laws and generalization are okay, they're all very well, but it can also be useful in some cases to use something different, use conceptual results, individual results that can apply only the case at hand and to use for your purposes. And Nate Silver, which is David, what is him? He's one of the most...
General forecaster.
Yeah, a general forecaster, very influential in the US debate, says explicitly that if you are, I quote from him, if you are concerned with prediction, it is convenient to give up generalization than to adopt this individual contextual perspective, because it works simply better. So, and that's what people are already trying to develop with algorithmic procedure. They are trying to develop techniques to control correlation independent of causation. To have, well, very simply, to check if the prediction is correct, even if you can explain that. And with machines, with all the computational capability, they claim that you can do it, or they are trying to experiment it. For example, a technique is like it's called data partitioning, a way to check and to control the result of the algorithm without claiming to understand how the machine works. Data partitioning, for example, you separate a portion of the available data, the so-called test data, from the rest. It is a very widespread technique. You separate that from the rest of the data, and the rest of the data is the training data that used to train the algorithm. But you keep the test data separate to check if the prediction is correct. So to check if the machine went in the correct way. Or another technique is called cross-validation, which is also very simple as the idea, but you train several machine learning algorithms on the available data, and then you compare them with each other. You say, if they reach the same prediction, probably they are right. If you don't, probably they are wrong. But you don't know, you still don't know how they are working. You want to control the correctness of the prediction, even without understanding what's going on. So they use techniques that don't rely on the need to understand the model, but they just want to check the correctness of the results. And there's an emerging theoretical reflection on that. Not very much, but some people start thinking about this. For example, David Weinberg, in a recent article appeared just a couple of weeks ago, claims that the current he was a writer in residence at Google for 2 years. He knows very well the field. And he claims that the current challenge dealing with digital procedure is to develop the form of control of rigor that do not require generalizability. They are not immutable, and often they are not understandable. We have to develop a form of control that admit the diversity of context, of moment, and of problem, and the primacy of accident and happenstance. We are pretty much strange, unique events also divination were related to. And I find no surprise that this debate, trying to find a new form of dealing with this phenomena, again, divination comes up. People talk in this debate, for example, of clairvoyance, referring to the words are sort of random in the field, but refer to a different way of dealing with the prediction, which is not contemplation of an already decided future, which would negate our open future, but still something that admits the open future. But the possibility to produce accurate prediction through processes that are, I quote, epistemically opaque to us, we don't understand, because understanding is not always required. Well, if I simplify a little, I could say that the idea is that we need to generalize and to understand and to explain, because in some cases we have to be able to apply the result to other cases to check if the results are correct. Generalization is needed to check the correctness of the prediction. But if this generalization is no longer required, because you can check in a different way, then understanding is no more necessary. That would be the claim in algorithmic techniques and also in divinatory techniques, as it was before. The criteria go in a different direction. But of course, everything is very speculative still, and I'm looking forward to the feedback and the discussion on this. Thank you.